Greetings, dear professors and students of Nanosemiconductor Engineering Department. We are the guided students of Professor Sung-Nam Lee, and now we're going to present about our capstone design project, oxide semiconductor-based flexible UV sensor. Our presentation composed of these 5 contents, and it'll take around 10 minutes. First, what is UV sensor? The device which increases current flow when UV light enters is usually called UV sensor. UV sensors are mainly used in flame detectors, wearable devices, and also light adjustment system in smartphone that you always carry with. According to the research of IDTech-EX, market size of global wearable technology is growing dramatically every year. Also, costs from Kotra expect that after COVID-19, market size will increase because high interest among public in healthcare. So, what are the main materials for those wearable devices, especially in UV detection? Cadmium sulfide, zinc oxide, PZT, quartz are mainly used for light detection. We selected zinc oxide due to its high 3.4 electron volt band gap energy, which is suitable for UV detection, and better thermal conductivity and non-toxicity compared to other materials. So, we have chosen 3 material candidates for flexible substrates. One is PI, another is PET, and the last one is fabric. Now, let me talk about properties of these materials. PI and PET substrates are transparent to visible light and very light and flexible, which is suitable for flexible substrates. For the fabric, although fabric substrates are opaque to visible light, but the application with fabric wearable device is unlimited. There are several distinct features of zinc oxide, which is it has a wide band gap of 3.4 electron volts, which means suitable for UV detection. And it has high transparency in visible light and heat conductivity. And lastly, its Urzai structure induces piezoelectric phenomenon, which is current flows when pressure is applied. We'll now move on to the mechanism of UV sensing. From now on, Jiok Choi will talk about it.
Now, would you look at the figure on the screen? The figure shows the principle of UV sensing mechanism. When semiconductor receives UV light, electrode and hole pair is generated. Generated electrode ionizes and detaches surface oxygen, so it lowers resistance and increases current. But when the UV light is blocked, an oxygen gas covers its surface again, and increase resistance and lower current. And next, there are several methods in growing zinc oxide like Jorgel and ALD and sputter. As a method of debursting zinc oxide, we will use ALD. Why? For flexible substrates like PET and PI, characteristic ALD is used because it can grow film at low temperature, which is an advantage of ALD. And also, ALD process can control property of debursting film in high precision. It has tons of advantages compared to other debursting methods, as you can see. And next, electrode deposition method include Schottky barrier diode and MXM structure and TFT structure. After that, we selected the MSM structure to electrode deposition. The characteristics of the MXM structure include lower series resistance and high current density and relatively simple process. The conventional semiconductor uses rigid substrates like silicon or sapphire is breakable and requires high temperature process. But flexible semiconductors such as PI, PET are not. Low temperature grown zinc oxide by ALD is unbreakable and foldable. Because of these features, they have unlimited potential towards semiconductor research. The following section is research target. Jae-eun Lee will talk about it.
Would you look at the table on the screen? It is a table that summarizes data of research paper related to the flexible UV sensor. The researchers focused on photocurrent, responsivity, and light decay time in condition of specific bias and wavelength. By referring to this, we have set up our research target. So, we set our target specification of device like this. Specifically, a condition of 5V bias and 365 nanometer UV light, the photocurrent above 5 microampere, the light time as under 150 sec, the decay time as under 1000 sec, the responsivity to over 0.5 ampere per watt, and it does not generate yellow luminescence in PL measurement. Let me see the overall process of the research. We will proceed in 5 steps. First, we will use ALD to grow zinc oxide on a flexible substrate. Second is the device fabrication step of depositing metal using a summer evaporator. Third, the properties of the completed device are analyzed and evaluated. Next is bending test. We evaluate the bending features using the designed test method and experiment. Finally, the prototype through system programming using LabVIEW is completed. In the thin film growth process, we set polyimide PET and fabric as the flexible substrate. As mentioned earlier, we plan to deposit the growth material as zinc oxide with ALD in an MSM structure. In addition, due to the characteristics of the flexible substrates like PET and fabric, a low temperature process of 200 Celsius degree or less is required. Move on to device fabrication, which is the step of depositing metal with a hard mask. The spec of the MSM structure hard mask is as follows. The sensing area is 0.1 square millimeter, and it is planned to deposit 40 nanometer thick aluminum contact using summer evaporator. The next section is analyzing and evaluating. From now on, Jung-hyun Kim will talk about it.
Our final goal is to improve the response time of flexible zinc oxide UV sensor. So we will evaluate surface quality through ON and AFM, optical property through UV visible and PL, and electrical property with hole measurement and probe station. And also, we will evaluate electrical property of device like IV curve, photocurrent, optical gain, responsivity, time-dependent current, and light decay time. The key point of our project is flexibility. When substrate is bended, piezoelectric effect occurs and change zinc oxide film's electrical properties. We are going to make jig and measure electrical property with it, because structure called jig helps to hold substrate in precision. So we can analyze changes in electrical property induced. Next, this slide is our team's research schedule. As you can see, the red arrow indicated planned research schedule, and the green arrow is the current progress. Our team is made up of 4 students. Team leader Jong-hyun Choi is in charge of growing films and measuring surface quality. Jung-hyun Kim is in charge of measuring optical and electrical property and conducting paper researches. Jae-eun Lee's role is designing bending test and programming prototype work. Jiaochu's role is measuring electrical properties and contact deposition using thermal evaporation. Thank you for watching. Any questions are welcome.